Welcome to the AGWA Automated Geospatial Watershed Assessment Tool video series. AGWA was developed by the University of Arizona with the USDA ARS Southwest Watershed Research Center and the US EPA. AGWA is available at www.tucson.ars.ag.gov/AGWA. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is the fifth video in this series, Parameterize the Watershed for Pre-Fire Conditions. Watershed parameterization is the process of defining the physical properties of the watershed. Parameterization creates a unique set of properties for each hill slope and channel element by intersecting the topography, soils, and land cover data with the discretized watershed. To parameterize the watershed, go to AGWA Tools, Parameterization Options, Parameterize. Notice the other parameterization options available. Batch parameterization allows you to run several at the same time. Add diversions includes side channels. Add storage adds detention basins or ponds. And add base flow accounts for perennial flow. For this tutorial, select Parameterize to parameterize a single watershed, the Andreas Canyon watershed. In the parameterizer form that opens in the input box, select the discretization created in video 4, CSA_acres140_VARS_0M. Name the parameterization pre-fire. This is the watershed before the mountain fire. Next, parameterize the elements, the hill slopes and channels, by selecting Create New Parameterization, and then click Select Options to open the Element Parameterizer form. The element parameterization describes the physical properties of the hill slope and channel elements. In the next box, Slope Options, select Uniform Hill Slope. AGWA can also provide an optional complex slope to describe an S-shaped hill slope, but will not be using this option. Next, we identify the flow length. This is the length of the water flow path from a source on the hill slope to the channel across the hill slope or plane, and is based on the flow direction. There are two flow length options. The first is geometric abstraction. This assumes that the plane is a rectangle where the length is equal to the adjacent channel length and the width or flow path is equal to the area of the plane divided by the length. The second option is the plane element. This option calculates the mean flow length of the plane using cell distances and areas. We're not using this option, so select geometric abstraction. The next step is to define the hydraulic geometry of the channel. The hydraulic geometry relationships define the bankful, channel, width, and depth based on the watershed size, physiographic region, and published relationships. If you have this information, you can edit these inputs. Select Pacific Mountain System from the drop-down menu. You can click on the View Map button to see the physiographic regions for the Andreas Canyon area. Next, we define the channel type. AGWA provides three channel types: default, natural, and developed. The default channel is equal to the natural channel, which has a sandy bottom and high infiltration. It's a winding but clean channel with a Manning's End roughness of 0.035. The developed channel is concrete with no infiltration and a low Manning's End roughness of 0.010. AGWA provides the option to create a new channel type or edit an existing one by clicking on the Edit button. For this exercise, we'll select the natural channel type. Andreas Creek is perennial, so we'll need to edit the channel description. Click the Edit button. Change the hydraulic conductivity to 0. Leave the other values as the default. Change the channel description to Modified Natural. And then click the Create button, and notice that the channel name is now Modified Natural, and the hydraulic conductivity is set to 0. Click Continue. The channel and plane elements are now defined, and you'll be returned to the Parameterizer form to perform the land cover and soils parameterization. In the Parameterizer form in the Land Cover and Soils box, select Create New Parameterization. Click Select Options to open the Land Cover and Soils form. And in the Land Cover tab, select the Land Cover raster from the drop-down menu, NLCD MTN FIRE. Select the lookup table, MRLC 2001 _LUT _FIRE. This is the land cover lookup table that includes all of the land cover types with their hydrologic soil group, which indicates runoff potential, percent cover, interception, Manning's N, and percent impervious surface. Notice at the bottom of the table are some of the vegetation cover types with additional values based on burn severity, low, moderate, or high. Agua uses this table to get the values it needs for the hydrologic models. In the Soils tab, select the Soils layer, Statsco _MTN FIRE. Navigate to and select the Soils database that contains the tables of soil properties needed for the hydrologic models. This database should be in your GIS data folder under the Mountain Fire tutorial. All of these databases have the same name, so make sure you select the correct one. Click Continue and then Process on the Parameterizer form. This completes the parameterization for the Andreas Canyon pre-fire condition and creates the lookup tables for the hill slope and stream elements. Close the form. The next video will show how to prepare the precipitation data for the Kinross 2 model for the Andreas Canyon watershed.